Let's practice Fischer projections with this worksheet. There's 3 different things that we're going to do on this worksheet. We're going to find chiral carbons in molecules. We're going to draw in enantiomers, which is not something that I talked about in the last video. And we're going to convert molecules to wedge dash notation. And I think you're going to find that all of these things are pretty simple. So as far as locating the chiral carbons, these Fischer projections are a lot bigger than the one that we did in our notes, and the one that we had in our notes was kind of like this. Like, this might not be exactly what we had. I might have the atoms in the wrong spot, but I told you that the center of the 2 lines right there, that was the chiral carbon. And if you have a more complicated Fischer projection like these ones, every spot that the 2 lines, the horizontal and the vertical lines, intersect, every one of those places is a chiral carbon. There's a chiral carbon located at the intersection of every single horizontal and vertical line. So that's pretty simple. Like, that's all there is to it, and we don't need to make that any harder than it needs to be. Let's skip down to number 3, converting each one to the wedge dash notation, because this is also something that we practiced in the notes. So on the notes, I told you that all of the horizontal bonds were wedges. That's what's implied in the Fischer projection, and all of the vertical bonds are dashes. That's what's implied. So same thing, even when the molecule gets more complicated, the horizontal bonds are always the wedge bonds. And see, this looks like just a row of little bow ties, just like that. And the vertical bonds are dashes. Typically, when we have a big molecule like this one right here, we will not draw dashes for these in-between spots. We will only draw 1 dash at the very top and 1 dash at the very bottom, and we'll leave those in-between spots as just regular straight lines. So we're just going to leave those ones alone. Let's try this on the next one. So draw your bow ties, your horizontal bonds. They just look like little bow ties. And then the very top is a dash, and the very bottom is a dash. See, this is pretty simple. Draw your bow ties all the way down. Every single horizontal bond gets a wedge, so every single one is a bow tie. The very top is a dash, the very bottom is a dash. And then there's one more. Horizontal bonds are the wedges, the bow ties. Very top is a dash, very bottom is also a dash. So now let's do the last part, draw the enantiomer of each molecule. And when we were drawing enantiomers with the normal wedge dash notation, so if we had the normal wedge and dash notation, I told you there were 2 different ways that you could draw the enantiomer. One way would be to just draw the absolute mirror image like this. That's one of your options. The other option that you had was to leave the molecule alone, like basically reproduce it, but then after you've drawn it, convert the wedge to a dash and the dash to a wedge. So that was your other option. When you're using the standard wedge and dash notation, these are your 2 choices that you have for drawing an enantiomer, and you can use whichever one is easier for you. With the Fischer projection, I'm going to encourage you to always just simply draw the mirror image. That's definitely the easiest way to do this. So we are just going to draw the mirror image for this molecule, and notice I'm starting with the horizontal bonds because those are the easiest ones to draw. And I'm going to do the one up on the top, and then I'm going to do the CH3 down on the bottom. And I literally just mirror imaged that whole entire molecule. Let's do the next one. I'm going to do it right here because I don't have room off on the other side. So I'm just drawing this molecule totally backwards. But I'm going to do something funky down here on the bottom. So see that I did not mirror image this part right here. And that is okay. You're allowed to do that. You're allowed to leave the top of the molecule and the bottom of the molecule. If you don't want to draw those as a mirror image, that is okay. That is allowed. You are only required to mirror image at the sites of chirality. So what I'm highlighting in green, that's the part that must be mirror imaged, and the rest of the molecule can go one way or another. That's really confusing for a lot of students, like when can I mirror image and when can I not mirror image? So my advice to you is to just always mirror image everything 100% of the time. It's never wrong to just draw everything in its mirror image. You're never going to screw anything up if you do it that way. So that's what I'm going to do for the rest of these. I'm going to draw it just totally as a mirror image. And then when we look at some of the problems on sapling, I think that we'll see that some of them are using this option of not mirror imaging the very top and bottom. And we'll talk about it a little bit more there. But again, you can always do 100% mirror imaging. That is never wrong.